Welcome to Learning to Engineer. This system G1 of S has two inputs R1 of S and R2 of S. It has one output C of S. How to find out the transfer function when it has two inputs? This is one case of multiple input, multiple output systems. We are going to understand this concept with the help of a problem. Let's get started. When there are two inputs, as in this case, we have two transfer functions. The first one is C1 of C of S divided by R1 of S. This is the first transfer function, and the second transfer function is C of S by R2 of S. When we are finding C of S by R1 of S, we nullify the second input, just like superposition theorem. We make the second input to be 0 and find out the transfer function C of S by R1 of S. In the second case, we nullify the first input R1 of S and find out the transfer function C of S by R2 of S. In a sense that what is the output when you have only one input? That is the first case. And what will be this input when you have only the second input? That's the second transfer function. With this idea in mind, let's solve one problem. In this system, we have two inputs, x1 of s and x2 of s, and both have the same input, y of s. This means that y of s is affected both by x1 and x2. Our objective is to find out the transfer function due to the second input x2 of s, and in this pursuit we will nullify the first input x1. When this signal is made as 0, the feedback path is directly connected to the forward path. So let's redraw this a little bit. This is the starting point of the forward path, and please keep in mind that it exists as the straight line between the input and the output. So at this point we supply the input x2 of s, and this is where the forward path starts. This path is G1 and this path is G2. We do have another feedback after G2. Okay, this is the first feedback path and this is the second feedback path. And with this we are going to find out y of s by x2 of s when x1 is 0. The forward path transfer function is just G2, and what are the loops that's available here? This is the first loop, G1 into minus 1 minus G1, and this is the second loop, G1 G2 into minus 1. This is the second loop. So this is minus G1 into G2. Therefore, the transfer function is equal to the forward path gains, which is just G2, into delta. Delta is just 1 because there are no loops that is not touching with the first forward path. Okay, so G2 into 1 minus 0 divided by delta. Delta is 1 minus of sum of all the loop gains, minus G1 minus G1 into G2. These are the two loop gains that we have, and both of them are touching with each other. There are no non-touching loops in this case. So therefore, this is the transfer function. If we simplify this a little bit, it will be G2 divided by 1 plus G1 plus G1 G2. Okay, this is the transfer function of the system y of s divided by x2 of s, and we are doing that considering that x1 of s is 0. I'll give you a small exercise. Find out y of s divided by x1 of s, considering that the second input x2 of s is 0. Find this out and let me know your answers in the comment section. If you want to know basics of signal flow graph, you can check out this video, or if you are a fan of block diagram reduction technique, you can check out this where I've explained the critical rule for reducing a block diagram. And you can also try the same problem, finding y2 of s by x2 of s and y of s divided by x1 of s using block diagram reduction also. Okay, so try them and let me know your answers in the comment section. Thank you.